Hey everybody, Bill Sky, the Assembly Guy, and this is our second video on functions with stack frames. And I know the first video was a long one. If you haven't watched that one, I really recommend that you do, and there's a link for it in the description of this video. But it was a pretty long one because it's a pretty complex, oh, I shouldn't say complex, it's just a very involved subject and you really have to understand what's going on. But in this video, what we're going to do is we're going to talk about sending pointers to a function using stack frames. Now, why send pointers? Well, if any of you are C or C++ programmers, you know that you can call a function by sending a copy that's passed by value, or you can call a function sending an actual pointer that's passed by reference. So you can do that either way. Now, when you pass by value, you're making a copy of the data that you're sending to the function, and then the function processes it. But when you send a pointer, you're sending a pointer to the actual item, which means that you're going to be using less memory in the long run, and sometimes it can be faster. And we really need to know how that works in assembler language as well. Now, I say in assembler language as well, but what I mean is that the compilers will generate the assembler language code, and that's what we're going to be looking at. We're going to be looking at how does the compiler generate that assembler language code, and how does the assembler implement those type of functions. So we're going to do this on Windows. It's exactly the same on Linux, but I like to go back and forth between Windows and Linux, and ARM processors, obviously, and some of my other videos. So let's get right to it. So I have a Visual Studio 2022 project open here using the Komanetsky functions. If you don't know what those are, go back and take a look at my earlier videos on how to download those, and maybe I'll even put those out in the description of this video, where how you can download those. But really all these allow you to do is use my functions that allow you to print strings, print numbers, and all that kind of stuff. So I've got a project here, and if I go ahead and if I debug and start without debugging, and I built the project, you can see that it just says hello world, program ending, have a nice day. That's really all it does. So that's just a very basic program. So what we would like to do is I would like to write a function that adds up all the values in an array. And to do that, we have to send a couple of things. We have to send a pointer to the array, because we don't want to send the entire array. We don't want to make an entire copy of an array, which I don't even think you can do. But we don't want to do that. We still want to send a pointer to the array. And we also need to send the size of the array, the number of items in the array. So we're going to do that in Windows, and I'll mention what you have to do differently in Linux, and there's not a lot. So let's do it in Windows, and then we'll actually write the function. So before we actually write the function, let's create our array. So I'm going to call this a quad array. I'm going to define it as quad, and I'm just going to put some hexadecimal values. Now the reason I'm putting in hexadecimal is because they're much easier to read in the debugger, and you'll learn that as you get more experience. So let's put in some numbers, and these are all hexadecimal numbers. Now, one thing that I did when I was rehearsing for this video is I accidentally left out the H on one of these numbers, and when I looked at the totals that were generated, it was completely wrong. And that's because I had some hexadecimal and some decimal mixed up, and I wasn't doing my addition correctly. So it's really a good idea to always put in hexadecimal values. Okay, so how are we going to want to call this function? Now, before I actually do that, I always like to build to make sure I haven't typed something in wrong. And if I did, I know it's just that one line, number 8. Okay, so how do we want to do this? So what we're going to do is we're going to call add array. Now, we have to send add array some data, and you can't really do this. You know, a quad array, and then how many items are there? 7. You can't do that like you can in C or C++. So we need to somehow do that. Now, if you watched my previous video on stack frames, I show you how to do that, but we're going to do it here on Windows this time. So what I'm going to do is I'm going to push the address of a quad array. That's going to be my first argument. And there's a couple of ways you can do that. I'm just going to say offset a quad array. Now, if you remember, on Windows, the word offset, the keyword offset, obtains the address of that variable. And in this case, it would be the address of a quad word array. But in my first video on stack frames and functions, we did it on Linux. This actually worked. We could actually push the address, or we could actually push a value, or a literal, I should say. But you can't do that here. You can't actually push the offset. You have to put it in a register first. So what we're going to do is we're going to put into RAX the offset of a quad array. And actually, let me make sure. Yeah, actually, let's make sure that this doesn't work. I typed it in wrong. I typed a quad array. Let's see if you can do that. Yeah, you can't do that. So we move the address of a quad array into RAX, and I'm going to push RAX. Now you see me building every couple of lines of code because it really makes it easy to find out what line of code it is I screwed up instead of typing in 20 and then figuring it out. So I do a lot of those builds. All right, so that's pretty good. So it says undefined simple add array, but everything else is good. All right, cool. So we're going to push the address of the array onto the stack, and then we have to push. And before we push, because this is Windows, I'm going to move into RAX the length of a quad array. Now in Linux, you would have to set up a constant for that, and dot length of, if any of you have watched those videos, it'd be a good idea to look at those. But Windows doesn't have that capability, but they do have a keyword length of. Now offset doesn't have to be all uppercase, but I like to keep things standard. And length of is a macro that goes out and figures out how many items are actually in that array. So I'm going to put that in RAX, and I'm going to push RAX. So length of, like I said a little while ago, it is a macro in macro assembler, Microsoft Assembler, that goes out, figures out how many items are in there. It's going to put that number into RAX, and then we're going to push it onto the stack. So let's go ahead and build it and make sure everything's cool. I still don't have add array. That's fine. We're about to do it. Okay. So after we call that function, what's going to happen is that the sum of all the numbers in that function are going to be put into RAX. So what I'm going to do is I'm going to push RAX, and I'm going to call print 64-bit num hex. That's one of my functions, Komanetsky functions. And then I'll call print endl. And that'll print the next line. That's like a \n, for those of you that don't know what endl is. All right, so let's go ahead and build that. All right, looks good. Okay, so we just haven't created add array yet. So let's go ahead and do that now. And remember, the first argument is going to be the address, and the second argument is going to be the size of the array. All right, so before the end statement in my code, I'm going to say add array proc, and then I'm going to say add array np. So that defines the function. It doesn't do anything, but it just defines the function. Okay, so let's create our stack frame. Now this is exactly the same way as it is in Linux. It's almost the same way as it is in even ARM assembler language. So what I'm going to do is I'm going to push the old base pointer, RBP, and then I'm going to move into RBP the RSP. So that creates our stack frame. Now what I always do this so I don't forget to do it. I'm going to destroy my stack frame. So I'm going to move into RSP, RBP, and then I'm going to pop RBP. And that is destroy our stack frame. Now, if you want to learn more about what stack frames are, go ahead and take a look at the previous video I did, because I did a complete comprehensive overview of what stack frames are with graphics and pictures. It's actually pretty cool, if I do say so myself. But anyway, so go take a look at that, and it'll really help you out on learning what a stack frame actually is. Okay, so we create our stack frame. Now, we're going to have to do a couple things. First of all, we're going to have a loop that goes through this array. And it's kind of good that we can't see the array, because I don't want to hard code the number of items in the array. I actually want to use the argument. So I'm going to put some comments in here. I'm going to say argument number 1 is the address of the array. And normally argument number 1 on a 64-bit is RBP plus 24. So that'd be RBP plus 24. And again, if you don't know what I'm talking about here, it's probably because you didn't watch my previous video. I won't know more. I'm not going to say any more about it, But go ahead and take a look at that. Argument number 2, this is the size of the array, and that is normally RBP plus 16. Okay, so I always put comments like that in my functions just to keep track so I don't have to revisit or think too much about getting those arguments. Okay, so let's go ahead and put in the code. So now that we know the address of the array, I'm going to move into RSI RBP plus 24. Now, how did I know to type that so quickly? Because I put these comments in there. A little bit of comments really helps things out. Okay, now I'm going to move into RCX, the number of items in the array, RBP plus 16. Now, I don't like size of the array because size of means one thing in Windows, number of items in the array. I'm a little bit obsessive compulsive about lining things up, but maybe that's because that's why people liked my code so much. Anyway, all right, so we've got everything set up. We're going to put things into RAX, so we're going to sum everything into RAX. So we're going to move into RAX 0. Now, some of you might say, well, why don't you do an XOR? Those two lines do the exact same thing, and neither one is faster than the other. I've actually went through that in a previous video. They're not faster. Neither one of them is faster. So moving a literal into RAX, I think it was the same speed as XORing. But anyway, so I like to use move. So that's our accumulator. So I'm going to put some comments in here. The address of our array. And this is the number of items in the array. That's our loop counter. RCX is our loop counter. And then that's our accumulator. Zero out our accumulator. Okay, great. So now let's do our loop. Now, the way that I like to do loops is that, or the labels for a loop, is I like to use the first letter of each word in the function and then give it a number. So add array loop 1. And then that's going to loop to add array loop 1. Now, if you don't know why I'm using loop or how loop works, I have another video prior to this one about using loops in assembly language. So go take a look at that one. That one can help you out quite a bit as well. Okay, so this is going to start at the number of items in the array, and then it's going to start our loop here. Now, what do we want to do? We want to add into RAX RSI. Why RSI? Because RSI contains the address of our array. So RSI, and that's kind of it. I mean, we're just going to add it. Now, we need to go to the next item in the array, so what I'm going to do is I'm going to add to RSI the size of each item in the array. Now, here's a thing you could do. You could send a third argument that says the size of each item in the array, but let's go ahead and just assume it's going to be 8. Now, what I'd also like to do is instead of add array, I'm going to say add quad array. So I'm going to change my function name a little bit. That's going to add up any quad word array. And that means I have to change my loop name. And you might be looking at this saying, man, this guy is really obsessive compulsive. Well, it's 45 years of experience making sure you get all this stuff done right. Okay, so RSI contains the address of our array. Now, we copied the address of our array into RSI, so we're not actually modifying the address that was sent. We're modifying the copy of the address that's sent. So it's not really affecting the address of the array. And that's pretty much it. Now, we could actually run this, but we need to back up our registers before we actually run this code. And the reason we want to back them up is because what if the main program that called addQArray, what if that was using RSI and RCX? Our function is going to blow them out of the water. So what we need to do is we need to back those up first. Now, we're not worried about backing up RAX because RAX is always the register that is blown up by a function. You as a programmer need to realize that whenever you call a function, that function is probably going to mess with RAX. So you can back that up in the main. But for right now, let's just go ahead and back up RSI. So the way I'm going to back up RSI, I'm just going to say push RSI, and I'm going to say push RCX. So I'm just going to push those onto the stack. And then right before we destroy the stack, I'm going to pop RCX. I'm going to pop RSI. Now, if you're not really sure what I'm doing there either, you might want to go look at the stack video that I did, and you'll better understand what all that is. So I'm going to put some comments there. I'm going to say back up the registers I plan on using. And this is just being a good citizen. And by being a good citizen, people are going to want to hire you to code. Okay, restore the previously backed up registers. Okay, let's put some more comments here. Add an array value to RX, and this says move to the next array position. So there you go. So our comments are pretty much very, very good comments, I think. Okay, now this isn't going to build because we renamed the name of our function. So let's go up here and change that to add QArray. All right, now let's build this. Now I wrote a lot of code here. I normally don't like doing that without building, but I wrote a lot of code, so let's build it and see. Oh my God, perfect. I'm such an incredible coder. Oh, I'm sorry. I was in my happy place there for a moment. Okay, so there we go. So let's actually see how this works. So what I'm going to do is I'm going to put a breakpoint right here in my function to move RBP plus 24 to RSI and move RBP plus 16 to RCX. And let's go ahead and run this. So I'm going to say debug, start debugging. Okay. Now let's take a look at some of our arguments here. Well, okay, so we really don't have any arguments. So we're going to be looking at RSI, and we're going to be looking at RCX. So right now RCX has this number in it, which it's good because the main might be using that. So we're going to back it up, and we already did. We backed it up here. So let's go ahead and see if our arguments come back correctly. So I'm going to step over, and there's RSI. That does look like the address of our array. Now, how can I make absolutely sure that is the address of our array? Well, I'm going to double click on that, right click and say copy. I'm going to go up to debug, Windows, memory 1, and I'm going to put that address in there, preceded by 0x. I'm going to right click on it, and I'm going to say 8-byte integers because it's quad. So it's 8-byte integers, and we can see our 100, we can see our 200, so that is the address of our array. So that's pretty cool. That worked out. So RBP plus 24 is the address of our array. I'm going to step over. RCX now has 7. Yes, I had 7 items in there, and you can go back up 1, 2, 3, 4, 5, 6, 7. 7 items. That's awesome. So 7 is now into RCX, and I'm going to step over. RAX now has 0, and we're going to add 100 to RAX. We get 100. Go to the next item, 300, because we added 200. So our code looks like it's working pretty darn good, or well, or whatever the English correct way of doing it is. Okay, so the loop is now over. It added all 7 of those items. We're now going to pop RCX. Notice that RCX has a 0 in it. That's not what our main had. So I'm going to pop that out of the stack. I'm going to pop RSI. Right now RSI has this number. Let's go ahead and pop it out. It's now got the previous number. Step over, step over. Oh, I did this when I rehearsed this video. This is driving me crazy. Guess what I forgot to do? I forgot to put the return in my function. It's funny that I forgot to do that, really doing it too. So the return says return from the function. It says free up 16 bytes out of the stack. That's what the 16 means. And why 16? Because we had 2 8-byte arguments. Okay, now so I know this worked. So I'm not going to debug it now. I'm just going to go ahead. I'm going to turn off that breakpoint. I'm going to rebuild it now that I actually put in the return. Did I save it? Let me make sure I saved it. Whoops. Make sure I save it, and then let's go ahead and build it. Sometimes I forget to save. Yep, looks like I forgot to save it. All right, good. I'm just going to run it now. So I'm going to say debug, start without debugging. and 1C00H. Now, how do you know that that's correct? Well, you go up there and you total things up. So you can use a little hexadecimal calculator, but 100, 200, 300, all the way up to 700 added together is 1C00H. It definitely is that. Now that you know that your address is working, what you can do is you can take off the H. And what it's going to save it as, it's going to save it as decimal. And then instead of saying print 64-bit, where is that puppy? Num hex, I'm going to say decimal. And again, these are my functions that I wrote for you guys. Debug, start without debugging. And that makes it a little more English-like. So 1, 2, 3, 4, 5, 6, 7, when you add those together, you get 2800. Okay, so that is passing pointers to a function. It's much like passing values, except you're just passing the address. And then what you need to then do is you need to put that pointer into some type of a register that you can then dereference to grab the data. This was a lot of fun. I enjoyed doing this. I love doing pointers. Hope to see you at our next video.